As the last topic of this chapter, we will discuss the force of friction. There are two kinds of friction. There are static friction and the kinetic friction. Static friction and kinetic friction. Static friction happens when we try to move an object, but it still does not move. As in this figure, you apply the force F to move this object, but at the surface, at the contact between this object and the surface has the static friction. You apply the force, but the object does not move. It means that it must be the force with the same magnitude, but in the opposite direction, and that is the static friction. Okay, this is a static friction. From our experience, we know that when we apply the force to the object, but the object still does not move, we may apply more force, mean increase the magnitude of the force, but the object maybe does not move. Okay, so it means that when you increase the magnitude of the applied force, the magnitude of the static friction increase also. So it means that the static friction is not constant. It's not constant. It changes with the applied force, and as we discussed, the magnitude, if the object still does not move, it means that the magnitude of the static friction must equal to the magnitude of the applied force. So if we plot the graph between the applied force F and the static friction, we will have this line, a straight line with the slope equal to 1. Okay, the straight line that the slope is equal to 1, because we have that the static friction is equal to the applied force. From experiment, we found that the static friction will increase with the applied force until it reaches a maximum value, and in this figure it is this point, the maximum value, and this is Fx max, maximum value of the static friction. And at this maximum value, we have that Fs max is equal to the mu s n. We call this coefficient mu s as the coefficient of static friction. The coefficient of the static friction. Here, N is the normal force. N is the normal force. That is the force against the attempt of the object that try to fall or to move through the fall. If the object is on a horizontal plane, this normal force is equal to the weight of the object. Okay, but this is not the general result, because sometimes N can be larger, sometimes N can be smaller than the weight of the object. Okay, and from this graph we can see that in general we always have that the static friction is less than or equal to mu Sn. Okay, the maximum value of the static friction is mu Sn, but it's always less than mu Sn or just equal to its mu Sn for its maximum value. Now, when the applied force exceeds the maximum value of the static friction, it means that the friction cannot increase beyond this value, and the object will start to move. We found in the experiment that the friction between the object and the ground or the surface will drop a little bit, and after that it becomes a constant. This constant is equal to mu Kn, and we call this friction when the object moves as the kinetic friction. So this is the kinetic friction. Okay, this friction is a kinetic friction. The constant mu K here is the coefficient of kinetic friction. Now we can see that from this graph that the kinetic friction is different from the static friction. That is, it is a constant. Okay, it means that it's not depend on the applied force, but once the object moves, the kinetic friction is a constant. Okay. In fact, from the experiment, we found that the kinetic friction also change, but with the speed of the object. But we will ignore these results here in our study in this course, and we will assume that the kinetic friction is a constant when the object moves. At the moment that the object starts to move, that is when the applied force is equal to the maximum of the static friction. We call this moment we call it the impending motion. It means that you cannot pending the motion anymore. It will start to move because the applied force exceeds the maximum value of the static friction. From the experiment, we found that both static and kinetic friction depend on the type of two surfaces at contact. Okay. For example, if you have the rubber on concrete, you will have the mu s equal to about 1 and mu k is equal to 0.8. If you change the surface, the type of the surface at the contact, the value of the mu s and mu k will change. This mu s and mu k does not depend on the contact area. Does not depend on the contact area, but it depends on the type of the two surface at the contact only. There are some pitfalls that we have to be careful when working with the friction. First is that the equal sign is used in limited situations. In this equation, okay, the equal sign is used only in the case in which the surfaces are just about to break free and begin sliding. Do not fall into the common trap of using Fs equal to mu Sn in any static situation, because this equation is valid only for the maximum value of the static friction, not in the general.